light is this is tackling Rayleigh scattering because I had said that that's not a thing and that it um, it is. That's my bad. And so light is not scattered more, but okay, so Rayleigh scattering is a thing, but I think that the reasoning behind it is wrong, and so I am going to tackle it here potentially, or just discuss it a little bit. I may have come up with some better logic, but I don't remember what I wrote down here exactly. So let's see. Light is not scattered more because of its wavelength. It is based off of its energy, more specifically, its velocity, and as such, its mass, with the two being interlinked. What has happened is that the energy of the smaller wavelength light is proportional to faster velocity. This results from a smaller mass. Because they have a smaller mass, they are much easier to influence by external factors and are more free to move as such. This leads to higher energy light scattering in all directions more than lower energy light. As the size of the particles in the medium increase, so does the scattering effect of all light. This is because the mass of the particles in the medium become large enough to influence more types of light. I'd like to apologize once again, as I was wrong to trash Rayleigh scattering. However, I do not think it is the only factor in why the sky is blue. I still hold that gravity of Earth that the gravity of Earth has an impact. The energy of photons is related to its speed, and I have said that particles with a faster speed also have a smaller mass. And because they have a smaller mass, this means that when they come across a particle, the mass of that particle is greater in comparison to it, right? And so it is more likely to be affected by its gravity than that of, a red light wavelength photon. And so what we see is that, in a sea of particles, this higher energy light gets scattered more sooner, right, than the lower energy light. And all the light is scattered, and the larger the particulate, the more of different light is scattered. And basically at the fundamental level, it has nothing to do with wavelengths, because I really don't understand the wavelengths being more likely to scatter because they're smaller. I really don't understand that line of reasoning. So I don't really understand that. Visually you can see it happening. Yes. There's visual proof when you just look at the sky, right? But I feel like, is it the wavelengths that's a thing? No, I don't think it's necessarily the wavelengths. I think it's the velocity that is the deciding factor there. Shorter wavelength is faster velocity. Faster velocity has smaller mass. Smaller mass is more impacted by gravity. It is more likely to come close to a particle and get flung off in another direction than that of a red particle, because red photons need to get closer to the mass, to any given mass, before it'll be effectively scattered. Because the light may get slightly bent off its trajectory, but it kind of evens out over time with all these photons flying around. But the probability of a larger mass being shot off in a direction is lower than that of a smaller mass, because of just how gravity works. And We just know that smaller masses are more affected or more impacted by gravity than a larger one is, right? Because they both have gravitational pulls, and when their gravitational pulls are closer together, they kind of pull on each other in a more equal way. Whereas the pull proportions between the smaller and larger is not equal. I don't know if I really need to go into more explanation on that argument. I feel like that makes sense. Anyway, and then I tagged on that, the sky is blue, and that has to do with Rayleigh scattering, but I also think it has to do with the fact that blue light is able to travel the farthest in our atmosphere. Purple, I think, is high enough energy that it kind of can fly back off into space. So we don't see as much of it. And I read something saying that our eyes don't see purple as well, so we tend to see more blue than the purple, or more blue than violet, because that's how our eyes are trained. I don't know if that's true or not, but if that is, that's another factor. But basically, yes, this blue light is getting scattered more, right? But it's also able to travel farther distances. And so it's this compounding effect of both of these things that allow for the sky to be blue and things in the distance to seem blue, and you to get like this blue look high up in the air, right? Lower to the horizon, things become less blue because there is more light, like wavelengths able to, wavelengths able to reach us. So I think it's a combination of both. I don't think it's one or the other anymore, right? I think it's both in tandem create this effect. And, higher density, higher gravity, slower motion, more energy used / lost, lower energy light falls off sooner. I drew basically just like, I talked about this in another video, the density gradients and the layers and stuff, right? I went into all of this in my video where I talk about, what was that term? It's when galaxies it's something rebound. I can't think of the term, but it's when galaxies that get farther away start to get bigger again, right? And so, basically, in that I talked about the different gradients of light or whatever, right? And so, as you fly down into these deeper levels, only the heavier, lower energy stuff is able to, penetrate as effectively. It's a combination of both. I went into like a full on-depth explanation of the gradients and how that works in our atmosphere and stuff in another video. So I'm not going to rehash it again here. But basically, I think it's a combination of that and then Rayleigh scattering. But Rayleigh scattering is not because of the wavelength, and shorter wavelength means it's more likely to get scattered. No, it's that shorter wavelength is higher energy has more velocity has smaller mass is more impacted by larger masses, it's more likely to be impacted by larger masses than a larger mass is, right? So naturally, the photons with higher mass scatter less because it is less likely for them to be in a scenario where they would scatter, from a probabilistic standpoint, right? And so they scatter less, and that's why the sky is blue. And I needed to correct my mistake of saying that that's not why the sky is blue. But I also needed to, say something about Rayleigh scattering because I don't like the wavelength explanation. So there's my explanation. There's all of that. Yeah. Peace out.